master thesis that I've already completed last year, and the title is called Investigating Small heat shock proteins in Endoplasmic Reticulum Stress. Before I move into the real content, I would like to introduce more about myself. I have completed both of my undergrads and MSc by research at the University of Birmingham, and now I'm a research assistant under Dr. Craig Doyle and participate in one of the projects that studies sex-specific response to glucocorticoids. And yeah, my master basically is an extension from the omics data. My previous lab PhD student was trying to overcome the challenges when studying skeletal muscles, as muscles that are complex and previous detection method in omics cannot really detect the protein in the insoluble fashion. Because of that, he used another type of cleanup method to dissolve the insoluble fraction so we can detect the protein within the insoluble fraction. And we can understand the proteins that change under the H muscle in a deep or greater details. And according to his omics, we found out that endoplasmic reticulum proteins that mainly related or located in endoplasmic reticulum increase in his omics data set. And actually, it indicating that under H muscles, endoplasmic reticulum is kind of abnormal. So, what does endoplasmic reticulum, or particularly sarcoplasmic reticulum in muscles, what does it does? It is a proteostasis regulator which mainly involving protein synthesis, protein folding, and protein quality control. And in a majority of stress, in an accumulation of protein, proteins, there have a stress mechanism that occur in ER stress, and basically, under an imbalance of homeostasis, a stress, namely endoplasmic reticulum stress, will happen under ER, and we can see there have three individual pathways that will be activated under the stress response, and they will just try to cope with the stress under endoplasmic reticulum. Yeah. So within the same omics data set, another group of protein, namely small heat shock proteins, is also increased in H muscles. From the omics data, 4 out of 7 has increased in the data set. So what does small heat shock protein does? According to literature, it's basically trying to hold the unfurled proteins. Under stress conditions, there will be having an accumulation of unfurled proteins, and at that moment, small heat shock protein will be activated, and they will perform their main function, which is a Holdase function to hold the unfurled proteins, and away for other chaperones protein like heat shock protein 90 to complete a proper protein folding. And this is what we know, or what is about small heat shock protein. And because of the literature, we know the function of small heat shock protein. And from the H muscle omics, we found out that both small heat shock protein, same as ER proteins, they both increase in the data set. But actually, no one really studied the direct mechanism between small heat shock proteins and ER stress. And my master is kind of direct. It's just trying to understand the function of small heat shock protein under ER stress, and our lab hypothesized that under endoplasmic reticulum stress, the small heat shock protein will increase as to hinder or reduce the unfurled proteins. So, what I did in my master, it has 2 chapters. The first chapter is to mainly validate the antibodies that ensure they are able to detect ER stress. And I induce ER stress with two well-known inducer that well used in the literature called tunica mousin or fepsigargan. And these are all the proteins that are well used to detect ER stress: chaperones and pathway-specific antibodies. And I use the well-known dosage that used on the literature and treat on C2, C12 myotubes. And what I do next is to know small heat shock proteins. How does they respond under ER stress in detail? I use a very different types of dosage to detect small heat shock protein in response to ER stress. And I have another set of data set that exactly having the same layout with the one that I showed in here. And small heat shock protein response to tunica mousin, we can actually see that under treatment of tunica mousin, small heat shock protein 6 and heat shock protein B1, they both decrease, and the others remain unchanged mainly. And the left will be the ER stress pathway specific antibodies or chaperones. And other types of drug. I also use a vary of doses, same as tunica mousin, and I detect ER stress antibodies and my target protein, small heat shock protein. And in fepsigargan, only small heat shock protein B6 decrease, and I would say the rest of them remain unchanged. So this is mainly what I did in my master that I wrote on my thesis. And to summarize, it's completely different with my original or the lab's hypothesis that small heat shock proteins goes down instead of increase under ER stress. And we think it might because of small heat shock protein. They perform the whole day's function. So they bind into the unfurled proteins, and they're just stuck in the insoluble fraction that I used to get when I collecting the cells or collecting the proteins. And the future work, the lab is trying to use different kinds of way, like different solution or other cleanup method to deal with the insoluble powder and to detect the protein expression in a greater details. And the data that I've presented was used for a poster presentation in the last year proteostasis conference in Cambridge, and manuscript is under preparation. And this is what I would like to share today, and I would like to say a big thank you to the people in both labs, especially Craig and Jordan, as they gave me numerous opportunities to learn and many chances to make mistakes. And I hope this will be only the beginning of my journey, and I'm looking forward to see what I can achieve in the future.